So for this video, we're going to still do integration by parts. So we're still going to be using, what is this, UDV, like UV equals UV minus voodoo, VDU. Alright, so we're still going to be using this formula. It's just the problems that we're doing might involve a little bit more than using integration by parts just once. So we might have to do it again until we circle back around to the beginning of our problem, but you'll see what happens. So, suppose we have an example like this. Now, remember the two guidelines were choose a u that when you take the derivative of it, it gets more simple, and then choose a dv so that you can actually integrate it fairly easily. And in this case, it seems like it doesn't even matter because so I mean, just normally I would just try something, and if it doesn't work, I would just be patient. I'd be very patient, and I try a different one. I try again. So that's what I'm gonna do. So this is what I'll say: u equals e to the 3x, and then right away du. Well, the derivative of the outside with the inside the same, e to the 3x times 3 times the derivative of the inside there. Okay, and then dx. And then I write down my dv. My dv, I'm gonna have cosine and the 4x on the inside there, dx. And then I need to get my v. Well, I guess I'll show that, but normally what I would do is I would guess and check. I know that there's a 4 on the inside, and if I was to take the derivative of v, I would have to use some kind of chain rule or something. So what I would do is I would just guess, because I've done this before, and so have you. What's the derivative of this be sine of 4x? I would guess this. And let's see. Derivative of the outside with the inside the same. Derivative of sine is cosine. 4x, good. Times the derivative of the inside. So I would have to multiply by 4. Well, if I multiply this by 4, it would go away, leaving me with nothing. So that's what it is. That's how I get v. I think that's how you should try and get v also. Hopefully you can get comfortable with that. And then I will use the formula. So I will take this and I will have a little. I'm going to take it slow. I'm sorry, it's going to be a slow video, okay? So I'm going to take e to the 3x cosine. I'm copying it down again. 4x dx. And that equals u times v. So e to the 3x times 1/4. And I don't simplify anything until... I don't simplify anything. I write it exactly how it is, just so I know where everything was. Sometimes I simplify, actually. Just kidding. So we have u times v minus the integral of v du, voodoo. V, which is 1/4, cern, e to the 4x, and then the 3 times the 3, I'm going to do it in blue. Why am I talking? Oh, okay. So 3e to the 3x dx. That's du. Yeah. And then normally, actually, this is something that I find very useful. I'm pretty much going to ignore all of this stuff, and actually the front here. But I like to circle the sign in front just so I know. Eventually, I'm going to have to distribute that. So really, what I'm going to work on, and I'll do it in red from now on. Maybe not from now on. I'm going to ignore that minus sign. That's why I put a circle around it. And I'm going to take this and move it back here. I'm not even going to move it back there. I'm going to rewrite it. Now I'll simplify. So, what do I have? I have, I'm going to bring the 1/4 out front and the 3 out front. So it's actually a 3/4. Hopefully you see what that's coming from. There and there. And then I like to have the e to the 3x in front. So I'll have 3/4 times the integral of e to the 3x sine of 4x dx. Now I know that this almost looks the same as before, except for now, like it used to be cosine, now I have a sine. But that's actually a good thing. So I'm going to actually do everything all over again. It's going to be super similar. If you start to think like, oh, it kind of looks the same, keep going and see if you actually get back to where you started, because that's actually what you want. So I'm going to start all over again, just trying to evaluate this integral. And then maybe I'll do it in green. So, again, I'm going to ignore that, so I'm going to circle it. Every time I ignore something out in front, I'm going to circle it. It just helps me keep track of it. So I'm still going to have e to the 3x du equals 3e to the 3x, same as before, dx. dv is going to be equal to, this time, sine, interesting, sine of 4x dx, which means v is, so same thing, 1/4 cosine. Derivative of cosine is negative sine, so I have to, I honestly, I just think about it, I say, it might be negative, and then I check. So the derivative of cosine is negative sine, so that negative will cancel out with that, leaving it with a positive, times the derivative of the inside times the 4, and that will get rid of the fraction there. Okay, so that's right. And then I will just do this integral. U times v, right? Still using the formula again. U times v. So u times v, e to the 3x times negative 1/4. I'm going to put that in parentheses. Cosine 4x. U times v minus the integral of v, negative 1/4 cosine 4x, du, which is that stuff. So times 3, I'm not going to put those parentheses, times 3e to the 3x dx.